All right, due to the great Wi-Fi outage of October 2020, we've got some problems here that we're going to just run through really quick. We have already done the questions across the top, so we're going to start at number 4. This is when you've got multiple triangles put together on the same picture, and to get a level 4, we're going to deal with one triangle and then move a piece of that triangle into the next one and then deal with that triangle. So that's how you get to that level 4. There's a couple problems on this sheet that are not level 4, so we can start there to kind of build up to the questions that have the 2 triangles fused together. So the 2 pieces, or 2 triangles that are not double, there's one right here. So this is just a normal basic triangle. You've got 1, 2, 3 angles involved. So remember that that is all 3 angles add up to 180. So we'll write that out. So we've got 2x minus 2, x plus 5, add that to the 90, and that total will be 180 degrees for the triangle. Okay, combine like terms, so we've got 2, 3 x's. We'll do negative 2 plus 5 plus the 90. So we did negative 2, 5 plus 90 is 93. Then we will subtract 93 from both sides. So it's 87. So 3x is equal to 87. Divide by 3. 29. Okay, so we do have a 90-degree angle here, so let's check this out. X plus 5, so 29 plus 5. We're just checking it out. So we've got a 34-degree angle here. We'll take our 29 times 2 minus 2 is 56. Okay, so for this triangle, if we had to classify it, it doesn't ask that, but if we were to classify it, we would classify it, its first name would be a right triangle because of the right angle. And its last name, because all 3 angles are different, that means all 3 sides are different. And if all 3 sides are different, we call it scalene. Okay, slide down to this one. So one of our 4 different theorems is the triangle angle sum theorem. That's this one. The second one is this exterior angle theorem right here. So we're going to figure that out in a second. That's the second one that we just did, but we're going to figure out this exterior angle using the theorem, even though you don't necessarily need that for this problem. And the third one deals with isosceles triangles and the fact that their base angles are congruent. So before we get to our fused triangles, we're going to see 3 of our 4 total theorems that we need to know to be at a level 3. So 42 degrees. I don't know these 2 angles down here at the bottom. I don't want to call them x because there's already an x in the problem. So you can call them y if you want. If you want to use a letter. So it would be y plus my 42 is 180. So subtract the 42 from both sides. Divide by 2. So here I have these 2 degrees down at the bottom are 69 degrees. Okay, but I'm trying to find x. There's 2 ways to do it. There's the easy way, which is the way I usually go with, Okay, so since this one makes a line with that 69 degrees, it'd be 180 minus 69 to get x, because that's a linear pair. So we could do 180 minus 69, which is 171. That's one way to do it. But there's another way to do it. So we want to bring about this just to practice and try to understand it more as much as we can. If you have an angle on the outside, this line extends out, the angle on the outside is equal to, not this one, but these two angles added together. So you could also find x by taking the two angles that are non-adjacent to the x, adding them together, and no, oops, I'm sorry, I wrote this down wrong. No surprise here, this is 111. This is also 111, sorry, my finger was a little off there. That's 111 as well. I only put 9 in there instead of subtracting 69. Sorry about that. Okay, so either way would get you the same number of 111 degrees for x. Okay, now let's fuse some triangles together. So we're going to go back to this idea of having 3 triangles adding up to 180 degrees over here. So anytime you have 2 triangles fused together, just take a second and see if you have a triangle where 2 of the angles are marked. So I know this is 47, this is 81, so I can easily find this angle here by doing 180 degrees minus 81 minus 47. Okay, so I write that out just so you know what I'm typing into my calculator. That's 52. Now, a very common piece of information that we will be using a lot is that if this one is 52, so is this one, because these are vertical angles. Vertical angles are going to become very important. We're going to use them a lot, so we need to know that when 2 lines intersect, the angles across from each other are equal. Okay, so that's what we're talking about, where we're using the information of one triangle to find an angle. Then we need to take that angle into the next triangle and use that information to find the x. Okay, now this is an isosceles triangle. So for that isosceles triangle, if this base angle is x, then this base angle is also x. Okay, so to find x, it's going to set up very similar to what we were doing here. X plus 52 is equal to 180 degrees. So 180 minus 52, it's 128, so 2x is equal to 128, divide by 2, and x is 64, so the 2 angles here are 64. Okay, let's keep along that same idea, especially with these vertical angles, and let's come up to question number 4, which also is going to have vertical angles in it. Okay, so kind of what I started with over here was I started with a triangle that had 2 angles marked so that I could find the third one. This one only has 1 angle marked. However, with these tick marks on the side, we know that this 68 can also go here. Now I'm ready to find the measure of angle 1 by doing 180 minus 68 minus 68. Which is 44. So I can put that 44 right in here where this angle 1 is. And then what we just talked about with the vertical angles, we can take that 44 and bring it across by vertical angles to make this angle 2 also 44. And again, we've got a set of congruent sides, which means we have a set of congruent angles. Okay, so that measure of angle 3, I can do measure of angle 3 plus the measure of angle 3 plus, or I can just do x. So I'll take 180 and subtract 44. Divide by 2. And you might look at these triangles here and say, well, they're the exact same number-wise or angle-wise inside the triangle. And that is true for this triangle and this specific circumstance. So don't necessarily think that if this is 68, 68, and 44, then this is always going to be 68, 68, and 44. That's not necessarily the case. Okay, last two. The last two do not have this vertical angle kind of look to it, but it does have something different. So you can kind of see on both 5 and 9, they have the two triangles that are fused together. And right here, we have a linear pair going on. So same thing down here, we have a linear pair where the two triangles are fused together. So that's the part we're going to use instead of using vertical angles. Okay, so both of these triangles are going to kind of start out the same, where we have this top angle, and although we don't know anything else, angle-wise, I know that this angle and this angle are the same. So again, we can call those x. So 180 minus 64 is 116. Divide by 2. So 58 degrees. So 58 is going to go here, but it's also here. Okay, so we just talked about linear pair. Linear pair can be used, but also exterior angle theorem can be used, which is what we kind of saw down here on question number 8, where we could do the problem in two different ways. I like the linear pair way. It just is easier because linear pair is something that we're going to use again and again and again. But it's understandable if you like addition better and you just want to add using the exterior angle sum theorem. Okay, so where we're going next is we need to find the measure of this angle 2 right here. So we just talked about two options. Option number 1 is to take 180, subtract 58, the one right next to it, because these two should add up to 180, and that'll give us the measure of angle 2. So 180 minus 58 is 122. That's it, 122. Now, if you wanted to go a different route for that number, we said to find this number, take not this one, so not that one, take the other two and add them together. So another way to get this 122 is you could have done 64 plus 58. That would also give you 122. Up to you how you get it though. Most people will use the linear pair. It's less things involved. It's something that we'll use a ton, so you'll remember it a little bit easier. But it's completely up to you how you end up doing the problem. When we finish up this problem, we kind of have this same sort of situation that we had at the beginning, where we know the vertex angle, the angle at the top, and we don't know the base angles. So what we can do is the measure of angle 3, I don't want to call it x because I already used x over here, so we can say y. So y plus 122. So subtract 122 from both sides, and you get 58. Divide by 2, and you get 29. And even though this one at the bottom, number 9, even though this one doesn't look the same, it only doesn't look the same because it doesn't have your 1, 2, and 3 in it. It's literally the same problem as we just went through on number 5. So what we're going to do is we'll save this question as kind of our warm-up for Monday. But you'll also know, I want you to know that on Monday we have time to review, so we'll just be going over questions from homework 10, and then we'll move into homework 11. So homework 10 is already up on GoFormative. Some people had some trouble earlier today getting that homework to let it continue because you hit submit. It just didn't update this morning because of the school Wi-Fi, so you should be okay now to go ahead and go back into that homework 10 and enter your answers online. But if something does happen, just know that you can always do your answers on paper and show it to me that way, and that's sufficient. Also remember that we are going to be checking our answers as we go with the answers that are written on the side, the back of each page. So this is homework 9, which we should already have done, but your answers for homework 9, for example, number 4, we got 47. So then what you should do is you should turn the page over and check to make sure that the answer 47 is an option, which it is right there. Okay, so as you're going through homework 10, whether you're doing it online or whether you're doing it on paper, when you get an answer, so I already did this number 7 and I got the answer of 45. When you get an answer of 45, you should go ahead and flip the page over and just check to make sure that 45 is an option. It is right there. And then you can feel a little bit better about getting the particular answers correct without necessarily using the GoFormative. Okay, so even if you're using the GoFormative and the answers aren't coming back, maybe they're coming back red versus coming back green, just go ahead and check back here with your possible answers and make sure that your answer is even possible. Okay, so that's homework 10. And then homework 11, that's this one right here, homework 11. This is going to be what you do in class on Monday. After we take a minute or two to make sure that any of you who are at home understand the remediation process and don't have any questions on remediation. So over the weekend, do try and finish up homework 10, but just know that we are going to be taking questions. That's all we're doing is taking questions on homework assignments, whether it be 9, 10, or 11 on Monday in class. And then finishing up with, hey, don't forget these things for your first-time assessment in class on Tuesday. So Tuesday we'll kind of talk about don't forget these couple of things before we take our first attempt at Standard 3 on Wednesday. Okay? As always, if you have any questions, just let me know. Because I won't be at school this weekend, my phone will work. my Teams will work and my phone will work because my Wi-Fi is up and running at my house. So let me know if you have any questions or if there's anything I can help you out with, and I hope you have a great weekend.